much coffee, man. He's too much coffee, man. He had a plan, but it all ran out the pan when he sat down to have another brown steaming cup of Java Joe, you know.
So we reviewed a USA Today article, and it was about how coffee intolerance may be grounded in your genes and why some people drink more or less of it. The two genes are CYP1A2 and AHR, and although we've known for many years that CYP1A2 is responsible for metabolizing coffee, we now know after this research that it's the same gene that is responsible for the differences in how people drink coffee. Neil Capozzo joined others from Harvard to conduct this experiment in which they surveyed and noted that 8 in 10 people who consume caffeine are in fact coffee drinkers. Caffeine is the most popular psychoactive substance, with 90% of the people in the world consuming some form of it. They pooled their data from intake patterns from more than 47,000 people of American and European descent in 5 different studies. From their research, they found that those who carried the highest consumption genotype of either CYP1A2 or the AHR gene consumed an extra 40 milligrams of caffeine compared with those having the lowest consumption genotype. This amount is equal to the amount of caffeine in 1 can of soda or 1/3 cup of coffee.
A new study published by PLOS Genetics found that our love of caffeine is genetically linked to the gene CYP1A2. McDonald's was thrilled by this news as it will now be able to recoup the losses from the decades-old drive-thru spilled hot coffee lawsuit by rolling out its new ad campaign. McDonald's coffee, it's in your genes.
The PLOS Genetic research utilized the Genome-Wide Studies Association. GWS stands for the Genome-Wide Association Study. This involves scanning markers across complete sets of DNA to find the genetic variations that are associated with certain diseases. Once these associations are found, researchers can take that information and develop better ways of detecting, treating, and preventing these diseases. In 2003, the Human Genome Project was completed, and thanks to that completion, researchers now have a set of research tools that make it possible to find these contributions to common diseases. One of these tools is a computerized database that contains the reference human genome sequence. This is a map of human genetic variation. This research has laid the groundwork for personalized medicine. Health professionals will now be able to take the tools and provide patients with individualized programs that tailor to each of their unique needs. There have been many success stories reported by the Genome-Wide Association. Some of these include genetic variations that contribute to type 2 diabetes, Parkinson's disease, and heart disorders. This study is conducted by taking people with the disease and similar people without the disease. Researchers obtain DNA from these patients by drawing blood or harvesting cheek cells. These cells are then purified, placed on chips, and scanned through laboratory machines. If the genetic variations found are considered to be significant, then they are said to be associated with those particular diseases.
There are 2 alleles of CYP1A2. 1A encodes an enzyme that metabolizes caffeine quickly, and 1F encodes an enzyme that metabolizes caffeine slowly. AHR is a transcription factor that regulates CYP1A2. This diagram describes how AHR regulates the expression of CYP1A2. Although the diagram may seem complex, it is the same mechanism that is near and dear to our hearts, as we will see in the animation following this brief word from our sponsors.
The day's looking new and bright, and you're gonna start it right. Folgers starting to brew, the aroma's calling you. The best part of waking up is Folgers in your cup.
Mornings are brighter with mountain-grown Folgers because mountain-grown coffee has more enticing aroma than any other kind.
The best part of waking up is Folgers in your cup.
Transcription is regulated by proteins called transcription factors. These factors are proteins that are produced in the cytoplasm and eventually migrate into the nucleus, where they interact with DNA and activate transcription. These transcription factors only interact with specific genes, those genes whose transcription they control. Most eukaryotic species have over 1,000 transcription factors. Regulated transcription begins when a signal is received by the cell. This signal, often a protein, begins a signal transduction cascade that lets the cell know certain proteins are now needed. The most common activation event for a protein in a signal pathway is the addition of a phosphate group. That activated protein in turn interacts with another protein. This interaction leads to the phosphorylation of the next protein in the pathway. There is often a series of proteins that are activated by phosphorylation. At the end of this cascade, the final protein will be activated and then enter the nucleus. It must make this journey because transcription only occurs inside the nucleus. After entering through a nuclear pore, the protein interacts with the specific transcription factor responsible for activating mRNA production. As with the earlier proteins, the transcription factor is modified through phosphorylation. The activated transcription factor will next bind to an enhancer region. The enhancer is a region of DNA upstream of the transcription start site that binds a transcription factor. The transcription factor then binds to the DNA and moves to interact with the rest of the transcription protein complex, located at the transcription start site. When the formation of this complex is complete, transcription of the gene will begin. It is this sequence of events that ensures genes required for a specific tissue or only at a specific time are expressed appropriately.
Harvey, want anything special for your birthday?
Just a decent cup of coffee.
You're kidding.
I'm serious. Honey, your coffee's undrinkable.
It's pretty harsh.
Well, so's your coffee. You know, the girls down at the office make better coffee on their hot plates. Well, see you later.
And he didn't even kiss me goodbye. You know, if I could just make a decent cup of coffee, I could relax. So, relax. Why don't you try Instant Folgers? Tastes good as fresh perked. Good as fresh perked? I'll surprise Harvey for his birthday tonight.
Hey, great coffee.
It's Instant Folgers. Doesn't it taste good as fresh perked?
Better.
Better than those girls make at the office?
Honey, their coffee can't hold a candle to yours.
Instant Folgers taste good as fresh perked. Try it.
P450 stands for pigment absorbing at 450 nanometers. Cytochromes P450 represent one of the largest and oldest gene superfamilies coding for enzymes present in the genomes of all biological kingdoms. Cytochrome P450 proteins in humans are drug metabolizing enzymes and lipid metabolizing enzymes that are used to make cholesterol, steroids, and other important lipids. Mutations in the cytochrome P450 genes or deficiencies of the enzymes are responsible for many human diseases. For example, induction of some P450s, that is, by cigarette smoking, is a risk factor in several cancers, since these enzymes can convert procarcinogens to carcinogens. Humans have 18 families of cytochrome P450 genes and 44 subfamilies. The P450 proteins are categorized into families and subfamilies by their sequence similarities. P450 genes are identified by the abbreviation CYP, which stands for cytochrome P450. It is followed by a number denoting the family. The number represents the proteins with more than 40% sequence identity at the amino acid level, followed by a letter denoting the subfamily. The letter represents more than 55% sequence identity, and finally, a number representing the individual gene within the subfamily.
Dude, I'd be a mess if I had to give up my Joe. I have a full-blown addiction. Hopefully that won't come back to haunt me. Where did you get this? Who taught you how to use this thing?
You, all right? I learned from watching you!
Damn it, Billy. At least he's using good beans.
The USA Today article, along with the PLOS Genetics journal, show that genes play an important role in how much coffee a person drinks. This information is supported by what we already knew about the CYP1A2 gene. If you have the allele that metabolizes quickly, you drink more coffee. If you have the allele that metabolizes slowly, you drink less. These observations go beyond coffee, well into understanding how they might help metabolize some compounds of cancer drugs or several other drugs. Now that we know that it's grounded in our genes, coffee intake should generally be thought as safe, but always practice in moderation. Thank you and goodbye.
Too much coffee, man. He's too much coffee, man. He had a plan, but it all ran out the pan when he sat down to have another brown steaming cup of Java Joe. You know, yeah, too much coffee.